walkthrough of these examples from the textbook. Hopefully maybe this will help you having somebody walk through them live instead of just having to read them. And so we're going to deal with the factor theorem and the remainder theorem, and along in with that is some long division and synthetic division, and how that can help us work with polynomials. So the first example they're having us do is divide this polynomial, this third degree polynomial, by this linear factor, by x minus 2. Now, before I do this, if in a classroom, what I'll typically do when I'm teaching this, I'll talk about, well, how do we divide 3 into 17? Well, what the trick is, or maybe I'll make it a bigger number. How about 372? Or 172. So then what I do, well, I make a guess. I say, well, let's see, I know 3 times 5 is 15. So I'll write 5 up here. And then I'm going to multiply 3 times 5, and that gives me 15. And then you have to subtract it, which leaves you 2. And you bring down the other 2. Then you repeat the process. You ask yourself, what times 3 is close to 22? Well, I believe it's 7, because 3 times 7 is 21, which is 21. I got to subtract those, and that leaves me 1 left over for a remainder. So I can write 172 divided by 3 is the same as 57 with a remainder of 1. I can write it as 57 plus 1 over 3. I'm dividing by 3, and that's what we do. So we multiply, we subtract, we repeat the process until we get a remainder that we can't divide by the divisor. And that's what we're going to do with polynomials now. Okay, so to do this division, I'm going to set it up just like a division problem. X cubed plus 4x squared minus 5x minus 14. And then I'm going to ask myself, just like you did with numbers, I'm not going to worry so much about the 2. I'm just going to look at the x and ask myself, what times x is x cubed? When, of course, that's x squared. And now I'm going to multiply x squared times x minus 2. Typically, you won't write this step down, but till first learning about this, it doesn't hurt to. So x cubed, x squared times x is x cubed. X squared times negative 2 is negative 2x squared. Notice the way I'm lining up the like terms. If I have a space, like if I get a number that's not a like term, I want to, when I write this out, you want to notice if you're missing powers of x. If you do, it helps to leave yourself a little space here. We'll do one like that in a minute. So let's see. Now I haven't subtracted. I got to remember I got to subtract. So for this value, I have to subtract just like I did with the number. When I did the numbers, I multiplied, then I subtracted. When we subtract using polynomials, we change the sign. So what happens here is it becomes negative x plus 2x squared. And then the x cubes are gone. That was the point of that. We get 6x squared minus 5x minus 14. Everything else just comes along with for the ride. And then I'm going to repeat the process now. I'm going to say, let's see, can I delete this here part? Just a minute here. Nope, it's going to make me do the whole thing, and I don't want to do that. So what times x is 6x squared? Well, that is 6x. I'm going to multiply x minus 2 by 6x. That gives me 6x squared minus 12x. Now I've got to remember to subtract, change my signs. So that's going to give me, let's see, 7x minus 14. Then I'm going to ask myself, what times x is 7x? Works out that it's 7. So remember, I'm doing 7 times x minus 2, which gives me, let's see, can I move this up? So this works out pretty nice. This divides evenly because I get 7x minus 14, then I got to remember to change my sign. I get a 0 remainder. So that means this does divide evenly, and that's a remainder. So I get x squared plus 6x plus 7 with a remainder of 0. This will be important in a couple of minutes. So the nice thing about having that x minus 2 have a remainder of 0, what that tells me is that this polynomial factors to x minus 2, which is what I divided by, times what was left over as a quotient. What was that? X squared plus 6x plus 7. Now, what they're asking me is to find all the horizontal intercepts, and I certainly could have thrown this in a calculator, and I would have seen, let's see, it would have crossed the x-axis at positive 2, and it would have crossed the x-axis at a couple of other places. It probably would have been, it might have been something like this. I mean, I don't know exactly. I know that cubic functions look something like this. So it could look something like this. Now, what are those two other places where it crosses the x-axis? I know it's supposed to have 3 zeros. I know it's supposed to have 3 zeros because of that fundamental theorem of algebra says you take a look at the power, that's how many zeros you should be. Maybe I'm getting ahead of myself, but you probably know that from Algebra 2 or college algebra if you did that course. So what we want to do is find the other two zeros. I know x equals 2 is a 0, is an x-intercept. I'm mixing up my terminology, but okay, so let's see, what am I going to do here to get rid of this? Can I erase that? Nope. I guess what I'm going to do is I'm going to delete this. Okay. So I've got the x minus 2. I've got the x squared plus 6x plus 7. The easiest thing to do is try to factor this. And of course, the only factors of 7 are 1 and 7, and those won't, and because these are both positive, it can't be x plus 1 and x plus 7, because that would be positive 8 in the middle if I FOIL that out. It can't be negative 1, x minus 1, and x minus 7, because that would be negative 8 in the middle. It can't be x minus 1 times x plus 7, because that would be positive 6 in the middle, but that when I FOIL that, that would give me negative 7 in the end, right? So it won't factor you over the integers like this, as they say. So what we're going to do is we're going to do some quadratic formula work here, or completing the square, whichever one you want to do. So I'm gonna use quadratic formula, and I'm gonna try to I'm gonna try to solve this. Is that equal to 0? So remember, a is 1, b is 6, c is 7, and the quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So negative 6 plus or minus the square root of 6 squared is 36, minus 4 times 1 times 7, all over 2 times 1, which is negative 6 plus or minus the square root of, let's see, 36 minus 28, all over 2. It's 36 minus 28 is a difference of 8, isn't it? So that gives me negative 6 plus or minus the square root of 8 over 2. And of course, 8 breaks down at 2 square roots of 2. And I can factor 2 out of both these terms. So 2 times negative 3 plus or minus the square root of 2 all over 2, and that 2 cancels. So there's my other two zeros, and I'm going to write this out of, I know from all this work that I've got zeros of x equals 2, and that's my work before. I also know that I've got a 0 of x equals negative 3 plus the square root of 2. I also know I've got a 0 of x equals negative 3 minus the square root of 2. So that's the three places that it crosses the x-axis. So this is a try it now. I mean, you should honestly stop the video and try this yourself. And of course, you've got the answers in the book, so I don't know if I really need to do this, but I'll walk you through it if you want. So hopefully you've tried this problem. You're just watching me do it. So x plus 3 divides into 2x cubed. Now notice, one thing I'm noticing about this problem is I'm missing an x squared. So what I'm going to do is I'm just going to write 0x squared. You don't always have to do this. Sometimes you don't need to, but I'm suspecting we're going to. It leaves a space in my work so that in case I need it, it's there and I don't have to crowd everything in. So then I'm going to ask myself, what times x is 2x cubed? Well, I think it's x squared. So x squared times x plus 3 gives me 2x cubed plus 3x squared. So you kind of help to have that x squared term there. Now remember, change your sign. This is the step that people, if they're going to make a mistake, this is usually where people make a mistake. They forget to change the sign. The 2x cubes are gone. Now what times x? I'm going to ask myself, what times x is negative 3x squared? Well, I think it's 3x, now negative 3x. So I'm going to do negative 3x times x plus 3 and distribute. So negative 3x squared minus 9x. Then remember, change your sign. You're subtracting. Leaves you 2x plus 3. And then what times, let's see, it's almost can't see it in back of the writing, with the writing in back of it. So what times x is 2x? Well, I think it's 2. So 2 times x plus 3 is 2x plus 6. Remember, you got to change your sign. So that leaves me a remainder of negative 3. So this one doesn't divide evenly. That tells me that x plus 3 is not a factor of this polynomial. So I can write it this way, or the remainder of 3. I can also write it, here, let me get myself some room here. I can also write that remainder as, I can write it as x squared minus 3x plus 2 plus 3 over x plus 3. Either way works, any of that works. So hopefully that you're able to do that. Now, synthetic division, when you're first learning it, seems very obtuse. It seems like it's very abstract. You're losing your variables. And if you read the example in the book, they show you where it all comes from. I'm not going to bother doing that here. I just want to show you how to do this. So what you do with synthetic division, you ask yourself, if you have a factor, x equals, like in this case, x minus 3, you ask yourself, when is that equal to 0? Well, that turns out to be positive 3. So that's what we're going to divide. And then you pull the coefficients out of what out of your it is called a dividend, I believe. So we're gonna take the coefficients, and what I want you to notice is that there's no x term. So what I need to do this division, and I need to make sure I include a 0. This is crucial for synthetic division. You will get the wrong answer if you don't include missing powers of the variable. You bring down the 5. Now you multiply. I really hope this is not the first time you've seen this. If it is, it's going to take you some practice. Otherwise, it's probably just review. So 5 times 3 is 15. Now I add them, which is 13. And then I say 13 times 3 is 39. And then I'm going to add those two terms, so 0 plus 39 is 39. And then I got to ask myself, 3 times 39 is, what is that? 90 plus 27, is that 117? So that's 118. That's my remainder. Now, do you remember back when we did the long division? If I divided an x cubed term by an x to the first term, that left me an x squared remainder. So what I've got going on here is I've got a 5x squared. Notice it's 1 power less than the 3. That's because I divided by an x to the first. So I've got x squared, 5x squared, plus 13x plus 13, with a remainder of 118, and that's divided by x minus 3. And that's about all we can do with this. There's another cool thing that I'm going to talk about that I didn't see where the book talked about this. Another name for synthetic division is synthetic substitution. So back in the old days, if I had to evaluate, if I had to find what was f of 3 for this polynomial, or if I treat it as a function, I would have had to plug in 3 for x. Now when I evaluate that, I'm going to get, 27, right? 27 to the 3 to the third is 27. So 5 times 27 is what? It's 100 plus 35 is 135. And then 2 squared is 9. Negative 2 times 9 is negative 18. And I'm going to have to subtract that. I'm going to write that down right there. Then I'm going to add 1. So really, I've got 136 here. Let's see if I can erase that 5 and make it a 6. So 136. Now if I subtract 18, I get 118. And look what I got when I had my remainder. So another name for synthetic division is synthetic substitution. Sometimes it's a quick way to get the value of a polynomial at a point. I don't often use it, but you can. I mean, that's what it's telling us. And this is one reason why when we get 0 for a remainder, we know it's an x-intercept, or it's a 0 of the function, we call it. So one more problem before we go on to the next little piece. And actually, then I think you have to try it. You try it. What I want you to notice about this one is that this x cubed plus 8 is just the sum of 2 cubes, which tells me this is going to factor. Just so you know, see what we're going to get. This maybe will refresh your memory about the sum of 2 cubes. Okay, because this is an important factoring formula to remember. For this one, I know that if something cubed plus another thing cubed will factor to this, I know that this is going to be x cubed plus 2 cubed. So I could factor this to x plus 2, because that's the x plus the y, times x squared minus 2x plus 4. And I'm just using that factoring pattern here. When we do this division, we're going to get this for a remainder. It's going to have 0 remainder, and we're going to get that for a quotient, Okay, so just to keep that in mind. I mean, that's not what this exercise is asking us to do, but this is what happens because of that. Okay, so I'm going to do some synthetic division here. I'm noticing, remember, you're going to say set this equal to 0. Where does x plus 2 equal to 0? Well, that's when x equals negative 2. In the exercises, they're going to say do some division, and they're going to tell you x equals, so you don't have to do the sign change, and they've already done it for you. So for this one, I'm going to say negative 2. I see x cubed is a coefficient of 1. Then I don't have an x squared. I don't have an x term either. I do have an 8. So notice I did put in those zeros. Now I'm going to multiply 1 times negative 2 is negative 2. Add those terms. Negative 2 times negative 2 is positive 4. Add those terms. 4 times negative 2 is negative 8. We get a remainder of 0. Now to write out our problem here, I'm going to do x plus 2, because that's what I divided by, times, and remember, this is the coefficient of 1 degree less than that term that we started with. So x squared minus 2x plus 4, which, notice, that's how that factors. So you could have done this problem without synthetic division if you knew that factoring pattern. Okay, so here's a try it now. Why don't you stop the video, try it? Or you can skip right through this if you've already done this or looked at the answer they provided in the textbook. So I'm noticing they want us to do some division here. I'm going to do a little bit more than that, because one thing that's I'm noticing right off the bat and I'm noticing a common factor of x in each of those, I am going to factor that out. I know they aren't asking me to factor this thing, but I want to factor it out because it'll make it a little, I think it'll make it a little easier for us. So I'm going to decrease all those exponents by 1. I notice that I'm missing an x squared term. So when I write out my synthetic division problem, well, first off, I probably ought to say x minus 3 equals 0, x equals 3, so that's what goes outside. Then here's my 4x cubed, 0x squared, minus 8x minus 5. Bring down the 4, and I'm going to multiply, I get 12. Add those, I get 12. 3 times 12 is 36. Add those, I get 28. 3 times 28 is, what is that? 60 plus 18 is 78. And that's going to be 73. So what do I get when I divide this by x minus 3? Well, I get x minus 3 times 4x squared plus 12x plus 28 with a remainder of 73 over x minus 3. I'm just noticing I've got a common factor of 4 here. Did I make a mistake anywhere? Let's see here. I don't think so. I'm not seeing where I made a mistake, so I guess that's just how it worked out. Alright, so hopefully that helps you do this. We'll kick it down the road a little bit in the next slide. So there's a couple of nice theorems that come out of all this. If I know, oh well, yeah, here's that remainder theorem that I was talking about. That if you evaluate, let's see, is this what it's saying? Right, they're just saying if you look at the evaluate, that's what I was talking about. If you want to evaluate f of 3, that's going to be the same as the remainder, depending on the polynomial. I don't remember that a minute ago. And then it's a 0, and then a factor, well, a quotient or something I'm dividing by. So if I had, remember how we had the x cubed minus 8, and I was dividing that by x minus 2? I knew that x minus 2 is a factor because the remainder was equal to 0. And so it won't be a factor if the remainder isn't 0. That's the important thing to remember about that. So then we're going to pull that into the works here. They want us to find, they want us to factor, well, really, they want us to factor this polynomial. They're telling us that x equals 1/2 is a factor. In fact, it has multiplicity 2, so that tells me this polynomial, the graph of this polynomial, whatever it looks like. I mean, I know it's going to come down. I don't know quite what's happening. I know at x equals 1/2, it's going to probably come up in, let's see, it's going to bounce. It's either going to bounce from the top or it's going to bounce from the bottom. I don't know quite which way it goes. I'm suspecting the bottom, but I'm just wildly guessing. But we'll find out here in a minute. So let's see, let's delete this writing, and let's run some synthetic division with this. So I'm going to put 1/2 through. And so 4, -4, I'm not missing any powers of x, am I? I don't know why I wrote plus 12, but I wrote plus 12. Minus 3, going to bring down the 4, multiply, get 2, because remember, 1/2 times 4 is 2. That's going to give me -2. I'm going to multiply those and get -1. That's going to give me -12. -12 times 1/2 is -6, which gives me +6. 6 times 1/2 is 3. I get 0 for remainder. So it is, we just showed that, yes, this has remainder 0. X equals 1/2 is a 0, and that means we have a factor of x minus 1/2, or 2x minus 1 if you want to write it without the fraction. So now they're telling this has multiplicity 2. So all I'm going to do is, I don't want to go back to the original because I'm trying to break this thing down into something that's factorable, and that x to the fourth one is impossibly hard. So we're going to make it be an easier problem. So I'm just going to run the next synthetic division, and I'm using 1/2 again because they're telling me multiplicity 2 on my remainder here on my quotient. So I'm going to multiply 1/2 times 4, I get 2, I get 0. 0 times 1/2 is 0, bring down the negative 12. Negative 12 times 1/2 is negative 6, another 0. So that leaves me, I have got x minus 1/2 times x minus 1/2 times this 4x squared. Now, I know it's a squared term because I divided off an x to the first twice, right? So that reduced to a quadratic. So x squared, there's 0x minus 12. And I want to find the other intercepts. Well, don't I want to know where 4x squared minus 12 equals 0? I can subtract 12, divide by 4. X squared equals 3. So x equals plus or minus the square root of 3. So that's my other where the x values. Now we probably should write these things as ordered pairs. So 1/2 0, 1/2 0. I guess I didn't have to write that one twice. And then I'm going to have root 3 0 and negative root 3 0. In fact, I don't like what I wrote here, right? And this bothers me. I'm going to get rid of that one. There's only 3 x-intercepts. This has multiplicity 2, so that's why we can just write the 1. Okay, so hopefully that helps you do the sections in this problems in this section. We'll kick it down the road a little further next section.